Okay, good morning everybody. What I'm going to try to do with this video is make a coherent educational video so that you guys can use this as a reference to when you're doing your conversion, if you guys should choose to do so. One of the things I think the first thing you guys are going to need is to be not that bright, because what I mean by that is I want you guys to be dumb enough to not know whether you can do something, and too dumb to know that you can't. So that because people that know they can't do something, what do? You don't do it. So I want you to know you can do this thing, more than likely. It's just a matter of taking your time, not being in a hurry, and being able to figure out things. I'm going to try and point out a number of things that gave me problems in the beginning, so that you guys can avoid some of my mistakes. And if you guys have questions or anything, you can put them in the comment, and I will try to get back to you. The whole idea of this video is to give you a tool to work with that explains a lot more things, because the actual installation of the motor and that, it's not that difficult. Everything comes plug and play, so you can put the damn kit together on the table and fire it up if you've got the battery and everything. But the real issues come into play when you're trying to convert a street bike and keep the electrical system of the street bike working with a 72-volt system of the dirt bike. So I'm going to try and point out the pros and cons of things and see if we can get this thing up and running and give you that tool. Anyway, I think what we're going to do, the first things first, I'm going to show you some tools you're going to need. It's not going to be the be-all, end-all or anything like that. It's just going to be basic tools to get by. You don't need a fancy workshop, but there are some tools that are really nice to have, especially like tap and dies, so that you can thread, drill holes in metal and then tap in a thread to it so that you can put bolts on, so you're not dependent on nuts and bolts for everything. See, I have two tap and die kits, and they're basically pretty cheap. Let's see if I can find them here. Not sure where I put them. There we go. Okay, so this is your basic tap and die set. Okay, so these are all your taps right here. They different thread sizes and different thread constraints, and then underneath you have your dies. So those are the dies. So you can pretty much make almost any bolt and nut that you need if you have to. It's I have no idea what these sets cost now. This was an old cheap Chinese set from the Wayback Machine, and I have another set that I acquired. Well, you can pick them up at like any of your discount auto houses. You can pick them up. Probably Harbor Freight has them, and they're wonderful to have. You're going to need probably any bike build you're going to do. You're probably going to need metric socket set and metric Allen wrench set. So that's Here's my Allen wrench and socket set, and then I use my standard American SAE set for my ratchets and stuff like that, and extensions. Some nice things to have would be a drill press. They're not very expensive. If you can afford to buy them, it'll really aid you in fabrication of your brackets and things like that. And that's probably would be the major, one of the bigger tools that I would try to invest in if you can. And then I did my build entirely without welding. So you do not need a welder to do this, especially if you're using a good, regular, Japanese type frame, or even a old KTM frame or whatever. Most of your frames come with enough mounting brackets on them that you can fabricate between those points to make mounting brackets for your bike. Vice grip is always handy because you're going to be doing a lot of fabrication. And then a little mini grinder. Let's see, where's my mini grinder? A mini grinder is an essential tool, especially when you're dealing with metal. And you can get some pretty cheap mini grinders. The one I have is an old Hitachi mini grinder, and I think I paid 89 bucks for it. And you want to get a bunch of steel cutting blades. So this is your steel cutting blade. It's very narrow, and always, absolutely always wear your goggles and probably gloves with this, because pieces of this can fly off, and you don't want to lose your eyesight in the process. So, and a couple of little things, some hose and clamps are always nice, so that you can mount things and clamp them in place. Let's see. Just trying to think. So we got lots of clamps here. You could definitely want to use different clamps, and sometimes you're going to use pipe clamps. They actually are beneficial too. You're going to need some hammers for pounding out some of your metal, and ideally you want to get some oh shoot, let's see, where do I have that? Like a vice grip. It looks like a duckbill platypus basically. Let's see, I don't know where that is though. Well, here's the welding type of vice grip that you can use for clamping things together to work on. Oh, I know where that thing is. It's under there. I'm not going to dig it out. But the other thing you're going to need is drill bits, and they call them high-speed drill bits. But I have this set here. It was made by Kawasaki. And the most important thing in dealing with your drill bits is that even though they call them high-speed drill bits, they're not. These damn things, when you're cutting metal, you want them to go almost as slow as you can possibly get them, and use oil so it helps cut the metal. But when we're talking slow, we're talking slow. So, you get yourself a good variable speed drill. A decent cordless drill can do it, and then the drill bit, the drill press, that has pulley system on it, so you can slow it way down, and that's going to be a tool you're going to use a lot. The other thing is I have my electrical kit that you know, keep all my tools and things like, you know, strippers and crimpers and liquid tape, electrical tape, and then your multimeters and stuff like that, because you're going to end up having to test your wiring to determine whether there's continuity going through it, things like that. And then, let's see, one of the simple things is also, it's real nice, ideally you want a jack stand. I made mine, so, you know, just a simple jack stand. And then this, and there's a cut-off piece of I-beam, which is real handy for pounding out your metal and straightening and bending metal. So that is something that, you know, even if you got a flat piece of steel and put it on a table, you know, for pounding on, that would be an asset. So that's pretty much what we're going to get you started with. I can't really think of anything else. So let's go back on up to the bike and we'll get started looking at that. One of the most important tools that you can get is your manual for the frame that you're using. So if it's a Yamaha, you want a Yamaha shop manual, and the most important part of that manual is going to be your wiring diagram. I'll show you mine. And if you guys have never done any wiring, this is like a road map. And I don't know, I know an awful lot of you folks grew up in an era where they don't use, you guys use GPS instead of road maps. So I'm going to try and show you this thing here so you get a better idea of what it is, how to read it. Okay, so now here's my Honda manual. In the back of the manual is the wiring diagram. And you've seen me pull this out before when I was working on the bike. But let's go over some details here so that you have an even better idea of how this works. Let's see, I'm going to put a little light on the subject so that you guys have a better idea. Okay, so one of the things to understand is that there's a color code on all the wiring. Okay, so generally your green on electrical vehicles is going to be your ground, and in normal vehicles that would actually go to the frame of the vehicle and run, and that becomes your ground through the entire vehicle. Now on the bike, you don't really want to use your frame. You'd rather have, personally, I would rather have mine, my ground system as a floating system, so it's not dependent on the frame of the bike, so that in the event that something shorts out, you've got 72 volts hitting that frame. That can fry a lot of stuff. So by having your ground floating, which is separate from the frame, so nothing's connected to the frame that will carry a charge to through the ground and back to the battery. So, and by ground, it's your negative wire. Okay, your positive wire is going to come in generally that's a red line coming in on a positive feed. But as you can see, there's all these different color lines, and all of these wires, each different color-coded wire, goes to a different part of the motorcycle. And up across the top here, you look at where it goes. This is the speedometer, this is the horn, these sensors here you get rid of. This is a turn signal relay, and then you go on over front brake light switch, engine stop switch, those are no longer. The ignition switch, and I still use the ignition switch. So, and then you come up here, this is essentially your battery. And these are starter relays, starter motor, no longer function. So then you've got junction boxes where you go to. See what I mean is all the grounds went into this junction box. So, and then this will go back through and connects to your negative side of your battery here. So that provides the negative leads throughout. Then you've got your lights on this side. You got, see, this is where I said it was frame grounded. Well, that's no longer the case. I eliminated the frame grounding, so the system floats so that you're not as likely to get a short across. And then we eliminated the rectifier, regulator, everything. Neutral switch doesn't matter because there is no neutral. Now, side stand switch on my bike, what I did was I switched it around so that when the kickstand is down, it goes to a buzzer, and it lets me know that the kickstand's down so that I don't drive off with the kickstand down. Normally, what they do on the bike is as soon as the kickstand's down, the engine shuts down so you can't drive off. But that was something beyond my skill level to figure out, so I went with the noise, the buzzer on the switch, and that works real good. And all these sensors here, fuel injectors, non-existent anymore. This entire bank here goes into the ECM, excuse me, electronic control module. That controls the motor, all the stuff gone. So when you're taking this apart, you want to eliminate all the wiring that goes to all these things that you're not using. Get it out of the way so that in the later date, it's not there confusing you from fixing things. And okay, the fuel pump's gone, the fan control relay gone. This is all my fuses right here. And this is ignition, so that's that. Number one is ignition, and I believe that's this one. No, one is ignition, so that went to start the motor. Anyway, if you trace each one of these wires, and they each have a different color code on them, then you'll be able to determine where they go, what their purpose is. Like we got the horn switch that stays on, the clutch switch no longer, turn signal switch, that's good, and the dimmer switch, that stays good. Then all your lights are good, your horn's good. So most of this, I mean, half the wiring disappears in this build. So you guys take your time, learn to read this thing. Just sit and look at it for hours before you even start your build so that you get a real understanding of where each piece goes, and then keep this wiring diagram with you the whole time. Because you don't want to take out some wire that you need, but you do want to get rid of the ones that you don't need. So yeah, I think that's probably enough on the wiring diagram. Just spend the time and learn how to use this thing. It's not that hard. You know, if you look at it long enough, it's like a road map. You know, it tells you where, you figure out where to start. If you know what you're looking at, you can figure out, and you can look at the wires and you can tell where they're going to go. So take the time and look at this thing and get to the point where it's etched in your memory, and it'll really help you in the build. Probably the most important tool you're going to have. So with that, we're going to move on. Okay, some of the other stuff that's really important that you're going to get is you're going to get a bunch of manuals like from DKD. It tells you how to set up and function your speedometer. And it's really confusing at first, I know. I sitting there going, what the hell? But, you know, the things you're going to have to figure out is your ratios. The motor itself, the QS138, has got a gear ratio of 2.35 to 1. And then from my drive sprocket to my rear sprocket, I have a 3.08 gear ratio. So when you're figuring out your, let's see, your pole pairs, there's 5 pole pairs in the QS138. And then to figure out your pole pairs, your offset, you take the ratio of the poles, which is 5 times 235 times 3.8 for my bike. And you input also in the circumference. You can measure your circumference. And the circumference of my rear tire was 2,120 millimeters, which was 83 inches or something like that. But for some reason, when I put that in, my speedometer kept running fast. So I realized that that's not the setting it needs to be for the tire. So somewhere in one of the emails or something that I had, it said that the default for an 18-inch tire was 1680 millimeters. So I punched that in and I came out dead on the money. So you might want to, if your circumference and your ratios, your ratio, poles, and everything don't translate correctly, then don't mess with your ratio poles. Those should be accurate. Mine turned out to 36.19. But what you do is take your circumference of the tire and shrink it down if your tire is running fast, and mine was running fast by almost 50%. So it was just totally ludicrous. So anyway, I put the 1680 in for circumference, and that took care of it. So that's something that you're going to want to keep in mind. So like I said, 1680 for yours. These are the ratios for mine. Mine, it's 5 poles times the 2.35, and then that's the ratio on the motor, and then the 3.08 is the ratio from the drive shaft or from the drive sprocket to the rear sprocket. So then you multiply all that stuff together. So that's ratio times poles, and so it's 5 times 2.35 times 30 for mine, gave me 36.19. So that was correct. It worked out fine. Just the circumference is the one that for some reason didn't translate out the way that they said it would. So try the 16.80, and if it's an 18-inch rear tire, and I run a Kenda 450, which is a big tire. So that might help you out a whole lot right there. And then as far as the other functioning, this paper pretty much explains it all. So if you want to, I'm going to come in close, and then I'll back up a little bit so that you can see the whole thing. I'll try and scan down here. And you should get this paper with your DKD speedometer. So Anyway, hopefully this helps you guys out real good, and it's going to work. Now with your DKD also, you're going to, Electro gives you a pre-wired ignition for the dirt bikes, and it's just got 3 poles on it. And but they also give you a backup clip like this with the wires already set up to go for your electrical system. So just follow this as if you're looking at the clip, and each it'll tell you where every wire goes for your left turn signals, for your right turn signal, high beam, low beam, battery positive, ground, then your one line controller, and the CAN bus system is not, or CAN bus system is not something that we have. So those 2 wires, they're gone. Just get rid of them, because that just gets confusing, and especially when you've already got things going on that you're not sure about. You don't want to waste your time with that. So I hope that explains a bunch of things. Now we're going to move over to the bike, and I'm going to try and show you some things that we had to deal with. Okay, first and foremost, when you're taking your old engine out, you're going to want to locate your center sprocket from some strategic measuring points. So what I did, you've got a measuring bracket here that took the engine, originally a bolt that goes through, so you can actually measure off of some of this stuff. And then there's a bolt here that goes through, and then there's another one down here that goes through. So there's a number of places where I've mounted the thing. And most important, so you take these points, you can actually cut up a cardboard template. Pete helped me with this, coming up with that. He goes, I go, fuck, how am I supposed to figure out where my sprocket goes? He goes, well, you didn't measure it before you took it off, and clearly I didn't. I wasn't thinking that far ahead. So what we did is we took our measuring off of strategic motor mount points that were already on the frame, and then we mocked up the thing and put the sprocket in its position. We matched up the bolts on the cardboard, this where it goes, and then we mounted it so that we knew exactly where it went. So then when it came time to put the motor in, we could get everything mounted. And one of the most important things you got to deal with is, I don't know if you can see this here, that bolt right there, it's actually a drain bolt too. So you've got to make sure that it's away from your sprocket. You don't want it, because when I first put it on, I had it over here, and I'd already made up my brackets to mount the engine. I was real, oh yeah, this is great, man, I'm awesome. Well, it turned out that my chains started hitting this thing. So then I had to scrap everything I'd done, rotate the engine so that the sprocket came out, and then this was on the far side or lower side. You want it ideally down below, but you want it not in the travel of the chain, because it's going to start rubbing on that, and that'll destroy your engine in no time. So this bolt is actually a drain bolt for your, you've got your gear reduction on your motor. So this drain bolt, you're going to need to take off periodically, drain it, and put in new gear oil. So that's something to keep in mind. So my sprocket's right in here, and I was able to reuse my old sprocket cover, because I know a lot of guys leave their sprocket covers exposed, man. Bad idea. All it takes is anything, like especially when you're riding street bikes, you tend to use shoes with shoelaces. They get caught in there and they could tear your feet up real fast. So, word of caution on that. So now, I want you to look. Okay, so I have all these straps running here across to here. So this is a stock Honda bracket. This is a stock Honda bracket. And then I carved my strap in so that I could mount my motor bolts to the engine, or to the motor, excuse me, and give the appropriate twist to the thing so that I'm not hitting things like this or things like this. So line those up, and then you've got to line up your fore and aft or side to side engine so that it lines up dead straight with your sprocket. So you don't, because you don't want your chain coming in at an angle on your back sprocket. You want this to flow straight through to this and everything to be in line. So take your time on that. You can adjust out your things, but if you get your sprocket in here, there you go. If your sprocket in there right, hang on, let me get that light too so we can get some more light on this, as I'm not sure just how much you can see. There's no exterior light. So, there. So this is the bolt. Get that thing lined up. You rotate your engine until that's in position, and you want to get that sprocket in a position that is almost exactly the same position as it was before the, as it was on the internal combustion engine. So you can see there's the sprocket. And so take your time on that. There's no hurry. And the important part is, see, what happens is when you take the motor and everything out, your bike's going to kick down farther than normal. So what I did was I put some pipe clamps, brought my bike back to where this was fully loaded bike, and then that was, but even that you don't have to worry about so much as long as you get your sprocket in relationship to its bolt mountings, motor mounts, and but take your time and measure it out real well. So there's no hurry on this thing, because the more you hurry, the more problems you're going to have. So, and you don't have to hurry. It's not a race, it's a build. So yeah, and the more you hurry, the more frustrated you're going to get. So as you can see, we've got straps coming across here the motor can mount to, and straps coming out here the motor mounts to, and straps, bolts coming off of that. So we've got 1, 2, 3, I think about 4 mounting positions that everything was strapped to and rebolted. So it's not real hard. You can see the fabrication that goes into it, just cutting out little notches here and there. The other thing I highly recommend is, rather than buying new strap all the time, see if you can locate scrap metal that you can use that was left over from something. You know, if you guys work with a lot of stuff, you're probably going to have a lot of junk laying around. So try and take advantage of what you've got. It'll save you a lot of money and time. You know, you don't have to stop to go run somewhere to buy something. One of the big advantages I had, like this tray right here, this was all made from aluminum that was actually tracks that hold solar panels on the roof. Aluminum is real nice to work with, but you know, there's some places where it's vital and some places where you might be better off with steel. yeah, just something to think about. And then let's see. And then when I was telling you earlier about my kickstand, so this is it. I had to modify the existing switch completely and turn it around so that it worked in reverse of what it normally did. And that came out real good. I'm real happy with it. You'll notice a bunch of oil stains here. That's mostly from coming off the chain. So, yeah, and then the other thing that I did, you're going to find you're going to want spacers between bolts and stuff like that a lot. And I notice all the real good guys on TV, they go out and buy these nice chunks of aluminum with the perfect pitch and everything. Well, I'm not into doing that much. So, like this piece right here was made from a piece of 1/2-inch pipe. So I just cut the 1/2-inch pipe. I mean, if I had done aluminum, I might have been able to save, you know, a few grams here and there. But it's not an essential. You don't need to do things like that. You know, so a lot of spacers, you know, especially when you're moving the motor in and out for adjusting that, you can actually make that with regular pipe, you know, regular galvanized steel pipe, and it works beautifully. You know, you just have to be very slow in your cuts and accurate on your cuts so that you don't waste a lot of time and end up with inaccurate measurement. And as you can see, like down in here, I had some smaller ones. I cut a bunch for different things, and then turns out they didn't work, so I filled them in with others. So, you know, you can stack them too if it helps you to come up with the appropriate distance. And let's see, that's pretty much it on the fabrication. Yeah. So I think so far that's pretty much covered that. You know, the other parts you're just going to have to fabricate up things like I had a radiator in my bike originally, and that was on this side. Well, I don't need a radiator anymore, so I had to make a bracket to support the plastics where they should be. And it was important for me to make my bike continue to look like a Honda CRF 250L. So those are things you can do. They're simple and effective. So let's see what else we got here. That's pretty much it, I think. Oh, okay, here's some things that came up in the build, which most of you know about. I had a phantom leak of electricity coming out of the bike, and on the harness that comes up here and goes up to your starter switch, no, let's see, it goes up to the DKD speedometer. So there's no switch to turn it on and off. It's just hot all the time. And in being so, it allowed electric to go up and somehow jump something in the DKD speedometer and then come back and backfeed of 72 volts into my 12-volt system, which is, even though it was a phantom current, it's still feeding a dissimilar voltage into the bike. So after tracing and tracing, I thought it was the DKD speedometer at first, and I actually went ahead and bought another speedometer, and turns out it was not the speedometer. So you know, I kept tracing my wiring. And finally what I realized was there was no turn-off switch on those 3 wires coming in. One's a red, one's a black, and let's see, what's the other one? It was a yellow. Wait, what the hell was that? Okay. Anyway, red, black, and here we go. Let's see, I can see it up there. No, I can't really see what the other color was. It's red and actually white. And the white on that particular one is, red, black, and white. White with yellow. That white with yellow is the one that went to the one-line system in the DKD. The black is the negative, and the red is the positive. And in tracing the wires down, trying to figure out how to do it, I cut both the red and the black. And then I put a toggle switch in on the red. But apparently the one-line system brings in power too. So when I put the toggle switch on, I had flashing lights until you turn everything on. And I go, well, that's not what I wanted. So what I did is I took the toggle switch off the red line, and I figured, well, if the common line to both would be the negative. So I went ahead and resoldered the red line back together, taped it up, made it look good. And then I put cut the black line and made it individual to the switch so that the ground runs through the negative. And in doing so, that shuts the power down so it can't flow back to the battery. And that took care of my problem. You know, so what I'm thinking is that, you know, the controller, which feeds all the wiring out to the rest of the bike, does not shut off. And so you have to have switches between your controller and your DKD, and then you have to have a switch between your inverter, which reduces the voltage from 72 volts down to 12 volts, and that runs your 12 volt system. So to shut the 72 volts down from going into the 12 volt system, I put a toggle in the negative line off the 3 wires coming off the controller going to the DKD. And then on the other side, I have a button just before for the 72 volts going into the inverter. And so I can shut down the inverter from the other side so that no power is being fed into the 12 volt system. So by having those 2 systems, I can pretty much shut down most of the power to the bike itself. So that was pretty much the game. Now here, this is my inverter right here, or it's what they call the inverter. So that is pretty much the gist of the problems that I faced. I've heard other people saying that they were having problems getting their 12 volt system up and running, and they were having issues. So that may be the crux of the issues. But I can only say what for sure what it was on my bike, and I don't know whether my controller is flawed to allow that little, you know, microcurrent through, or that's just a characteristic of it. But anyway, we've gotten it taken care of, and it's definitely a bonus getting that taken care of. And it's nice to be able to shut the system down so that you don't have issues like that. Okay, this bolt came loose, which is surprising because everything runs so damn smooth on this. You wouldn't think there's any vibration. Although this piece of steel, I've got a little bit of, it's flexible, so. Anyway, I'm going to come around the other side and clip the rest of that plastic off while I'm talking. But, yeah, and then some of the things I did was like, I ran my power plug in for recharging the bike in through this cap here. I think you guys have seen that. So that's not anything rocket science or groundbreaking. It's just simply what it is. So anyway, if there's anything you guys can think of that you get questions about, you know, I'll try and help you out. I really want to see more people convert their bikes over to electric. I think you'll be just blown away at how much fun and how satisfying it is to have something that you built, put together. And as far as the dirt bike conversion goes, piece of cake. I think anybody can do it. You know, it's just simple fabrication, very simple fabrication, unmounting an engine and making sure your battery is mounted properly. And then the rest of the thing, most of the intellectual strain went into the electrical system, converting between 72 volts and 12 volts and making sure that they worked together and didn't cross paths. So at this point, I think we're going to let you go. This may be the whole video. So like I said, if you guys want to comment in the comment section, I'll be happy to get back to you and hopefully help you guys out. Because, you know, I could have used a lot more help. Not that, you know, because the kit actually comes with no instruction. You're basically just handed this stuff and everything plugs and plays together. And you're supposed to figure out how to mount it, which is fine. It's not a problem. But things like the rotation of the engine so that the chain is not hitting that drain sprocket would be beneficial. It did cost me probably half a day because I fabricated up everything, mounted it, got everything into position only to find out that was hitting the chain. So, and it's nobody's fault. I mean, you know, it's just the way it is. These Chinese bikes don't come with, you know, these Chinese kits don't come with a lot of information. And I think the guys at Electro are so busy making harnesses, they don't really have time to think about that. And I don't think they're doing the conversions themselves. So it, you know, you get into, and they're busy guys, so it's hard for them to break away and stop and figure out what your problem is. So I'm trying to make this as easy as possible for you guys. So I'll be happy to help you if I can. If I can't, you know, you'll have to go somewhere else. But most of the problems are pretty simple. You know, tracing wiring's a pain in the ass any way you look at it, and you know, that's something nobody can really help you with. That's something you're going to have to figure out on your own. But you know, it's all doable. Just remember that you know, you're too dumb to know that you can't do it, and you sure as hell can. And if you're so smart that you know you can't do it, well, good for you. I suspect that's going to hold you back on a lot of places in life, but you know, so be it. So guys, if you're thinking about building, go for it. You know, it's a wonderful exercise in mental stimulation and education, and it'll help you in all aspects of life to tackle things like this. You know, my age, to tackle something like this may keep me from losing my cognitive powers, because I'm getting old, and but I still got them, and I'm going to use them until I can't. So the idea is keep living until you die. Don't die before you're dead. So aloha, you guys. You take care, and I hope to hear from you. And I hope that this is of value. Anyway, if you find it to be of value, subscribe if you're not already, and like. And I can appreciate the support. It helps my YouTube channel, which is very, very small. I'm very limited audience. But you guys are awesome taking on projects like this. So do it and live to the hilt. All right, talk to you guys later. Aloha.